Hello students, now I am going to discuss about particle velocity, wave velocity, which is also known by the name phase velocity and group velocity. Particle velocity is the velocity possessed by particle when it is undergoing simple harmonic motion and the wave is traveling or the wave is propagating. We know that as the wave propagates, the particle oscillates or undergoes simple harmonic motion about its mean position. So that velocity of the particle is called as particle velocity. Now particle velocity is a function of time. Therefore particle velocity can be written as dy by dt. Now next comes phase velocity. Phase velocity is the velocity with which the wave propagates through the medium. Or you can say the phase velocity is the velocity with which the crest and the trough travels forward, or the compression and rarefaction travels forward. Now phase velocity is given by the formula omega by k. If omega we know that omega is the angular frequency 2 pi nu and k is wave vector 2 pi by lambda. So phase velocity will be 2 pi nu divided by 2 pi by lambda, that is equal to nu into lambda, that is frequency into wavelength, is the phase velocity. Now next comes group velocity. Group velocity is the velocity with which the envelope of a pulse propagates in a given medium, or it is the velocity with which the energy in the group is transmitted. You can see that a wave pulse, with what, to understand the group velocity, you can see this is a pulse of wave, with what velocity this wave pulse is moving forward. So this pulse of wave consists of different waves, okay, and this forms a pulse, and this pulse is moving with a certain velocity, and this velocity is called as group velocity. Now to understand the difference between phase velocity and group velocity, we can see this animation where I have got two waves. These two waves have different frequencies. Now I am superimposing these two waves, and the resultant is this. Now you can see here this magenta dot represents group velocity, and this green dot represents phase velocity. You can see that magenta dot representing the maximum amplitude of each group. This is one group, this is another group. You can see each group consists of large number of crest and trough. Okay, so this is called as group velocity. You can see this is a wave pulse. You can see it consists of waves of different amplitudes. So the maximum amplitude of this wave group is traveling with certain velocity. So this is called as group velocity. Okay, and the velocity of each of the pulses, individual wave, is called as phase velocity. So this is the difference between phase velocity and group velocity. Now you can see in our expression, perhaps you have understood now the difference between phase velocity and group velocity. Now group velocity is limit del k tends to 0, del omega by del k, that is d omega by dk is called as group velocity. Now the relation between group velocity and wave velocity is very important from examination point of view. Group velocity is d omega by dk. Now omega is equal to phase velocity into k. So group velocity will be d by dk of dp into k. In case of omega, I am writing dp into k. Now differentiating this, I am getting this. Now putting k is equal to 2 pi by lambda, so what we are getting, dp plus 2 pi by lambda dp by d into 2 pi by lambda, because k is equal to 2 pi by lambda. Now 2 pi I can take out, so this 2 pi and this 2 pi cancel out, so I will eliminate d into 1 by lambda. So differentiation of 1 by lambda is minus 1 by lambda square d lambda. So differentiation of this is this. Okay. So next, after little simplification, is that Vg is equal to Vp minus lambda d by d lambda of Vp. Okay. This lambda square will go up, and then after that, after little simplification, we'll get this relation. So this is the relation between groove velocity and phase velocity, or groove velocity and wave velocity. So if dv by d lambda is positive, then groove velocity will be less than phase velocity from this relation. This is called as normal dispersion. Now if dvp by d lambda is negative, then groove velocity will be greater than phase velocity from this relation. So this is called as anomalous dispersion. Now if dvp by d lambda is 0, then groove velocity will be equal to phase velocity. It is called as a non-dispersive medium. We'll learn about what is normal dispersion and anomalous dispersion later on. And now it is not important from this topic. So this was about your groove velocity and phase velocity. Thank you.